Hi everybody, this video is on the basics of functions. This is section 1.2 in your textbook. So by definition, a function is a relation that maps between set A and set B that assigns each element from set A to exactly one element in set B. We call A the domain and B is the range. So let's look at example 1. Is this a function? So we need 1A goes to exactly 1B. Well, this has repeating domain values, repeating inputs. That's not going to work for us. This is not a function. So you need to think of a function like a vending machine. So if I have a vending machine and there's going to be different buttons, this button might be for water, and this button might be for water. Two different buttons can take us to the same thing. But this isn't going to be a mystery button, and you press it and maybe you get a Coke, maybe you get a Sprite, maybe you get a Dr. Pepper. That doesn't happen. You pick which one you want. So maybe this is a Coke, and this is a Dr. Pepper. So X's cannot repeat. In example 2, we have our domains are going to be letters, A, B, C, and our ranges are going to be numbers, 0, 1, 2, 3. Now, it is okay that there are 3 domains and 4 ranges. That's okay. See how C maps to 2 and C maps to 3? We can't have that. That is like pressing button C, and we don't know if we're getting 2 or 3 yet. So X's repeat, so that's not a function. A goes to 1, B goes to 2, C goes to 3, that's fine. They all match up. We didn't use the 0 out of here, that's not a big deal. We would call this a one-to-one function because every X goes to exactly one Y. So down here in this third example, this is okay. That 1 goes to A and 0 goes to A, that's okay. That's having 2 different buttons that both give you water. So you press 1 on a vending machine, you get water. You press 0 on the vending machine, you get a water. That is totally fine. This is a function. Okay, so what if they don't list things and we can't test? We have to see if everything is a function here. Okay, so we have x squared plus y equals 1. Yes, that is a function. Negative x plus y squared equals 1. No, not a function, and I will explain why. So, because I'm squaring this y here, that means that if I put in a 3 or a negative 3, I'm going to get the same x value, and it will cause a repeated x. If I put in a 3 or a negative 3 here for this x, it'll cause a repeated y. Squaring would give you the same number. So no matter if I square a 3, I get 9, or if I square a negative 3, I get 9. We're allowed to have repeated y's, but we're not allowed to have repeated x's. So if you see a y squared, that is not going to be a function. Because if you put in a negative value or a positive value, you will get the same exact answer, causing repeated x's. The last way that we can tell if it's a function or not is looking at our vertical line test. And that's, again, looking for an x value with more than one y. So, for example, right here, we hit it twice, not a function. Here, we hit it twice, not a function. Over here, anywhere we draw a vertical line, we'll only hit our graph once, so that's yes, a function. And same thing here, anytime we have a vertical line, we're only going to hit it once, so yes, that is a function. Okay, we've been talking about domain and range a little bit, but you know what? We need to talk about it again. So the domain of a function is the set of all real numbers for which the function is defined. So if I look at A, it is a parabola. We know that these arrows go on and on and on and on and on for each negative and positive. As we keep going out, we get wider and wider. We are defined for any value. So I'm just going to write the fancy little r. You can write all real numbers. You can write negative infinity to positive infinity. Doesn't matter. Make sure there's parentheses on the infinities, though. On the next one, we see a nice little endpoint here, and then we are assuming that this keeps going, and it's an arrow. So on here, my domain is going to be from -4 to infinity. I'm putting the bracket on the -4 because that was an endpoint. If I erase this, you can see clearly that the closed circle there. Okay, in part C, there's a little bit of an issue here. You have been told forever and ever and ever that you cannot divide by 0. Dividing by 0 is undefined. For a funny, if you want to listen to it, just ask Siri what happens when you do 0 divided by 0. She has a really, really funny explanation about a Cookie Monster and having no friends. It's quite funny. But you can't divide by 0. So what would you put into this denominator to make it 0? The answer would be -5. Another way you could write this is negative infinity to -5, -5 to positive infinity. There is a gap there. If you would graph this in the calculator, and we're going to do a lot more with these functions later, it would have an asymptote there at -5. Okay, D looks kind of funny, so it's still asking you for domain. So what is it acting like an X and what is acting like a Y here? The input is your radius. The output is your volume. So what kinds of radii can we have? Can you have a negative radius of a sphere? Can you have a 0 radius of a sphere? No. So we would say 0 to infinity, not including the 0, because we would have to be bigger than 0 in order for this volume to exist. Okay, last section is evaluating a function. So I have two different kinds of functions here for you. I have just a regular old polynomial, and then I have what we call a piecewise function. So the first thing they ask me to do is find g of 2. So instead of an x, I'm going to put a 2. G of 2 is -2 squared plus 4 times 2 plus 1. Now notice how that negative is not like this. It's not negative x squared. It's negative x squared. So first I'm going to square, then I'm going to make it negative. So -4 plus 8 plus 1. That's going to give me 5. Now, here's just a change of a variable. They're saying instead of finding g of x, find g of t. So it's actually really, really simple. All I do to find g of t is I plug in a t. It's still a variable, so there's nothing that I can do. The last thing, they want me to plug in x plus 2. This is the one that is not fun. Whenever we have a binomial squared, you have to FOIL. So x plus 2 squared, then we'll make it negative. So sidebar over here, x plus 2 squared means x plus 2 times x plus 2. That is x squared plus 4x plus 4. So x times x is x squared, your outside's 2x, your inside's 2x, your last is plus 4. Now I didn't put any signs in between there because of this negative out front, so I'm going to just add in all those negatives. Distributing my 4 becomes 4x plus 8, and then I have my plus 1. For a final answer of -x squared, these cancel out. So that's plus 5. Okay, the last one is called a piecewise function. There are two pieces, and we have to determine which piece to use based on the domain value. So let's look at the first one. They say let's find f of 1. We have to see which category 1 fits into. Is it less than 1 or greater than or equal to 1? It's greater than or equal to 1. 1 is equal to 1. So I'm only going to plug 1 in to the bottom function. So f of 1 is 1 plus 4. Same thing with 2. Is 2 less than 1 or is 2 greater than or equal to 1? It is greater than or equal to 1. So I'm going to plug into the bottom equation. But negative 3 is less than 1. So when I'm finding f of negative 3, I'm actually going to plug into the top equation. Why? Because this value right here fits into this top category of being less than 1. So I'm going to plug it in up there. 2 and then negative 3 squared minus 1. I'm actually going to square the negative 3, which is going to give me 9. So that's 18 minus 1 is 17. Okay, now you are going to, hopefully you were copying this stuff down in your notes on the packet that you picked up, and then there is a sheet for you to do. I did a couple of examples throughout the sheet so you can look at them and kind of see some examples on how to do it.